Hi everybody, welcome back. We're at 6.4 Hypergeometric Distributions. And the only and biggest difference between the previous two, binomial and geometric distributions, and this one, the only and biggest difference is when the repeated experiments are not independent. Then we have this hypergeometric distribution comes up. Not independent means they are dependent on one another. So when we have situations that are dependent, we use what's called the hypergeometric distribution. Another big difference is we're not going to be talking about A or P and Q anymore being the probability of success and failure. Instead, we're going to be making groups of successful outcomes and failure outcomes. So A is the group or number of successful outcomes, and B is the group or number of failure outcomes. If a process involves n trials, then the probability for the hypergeometric distribution is given by this. Out of the group of successful things A, choose x of them. X is how many successes you want. Out of the group of unsuccessful or failure outcomes, choose n minus x. That's the rest have to come from the failures. That gives you your NA on the top. NS on the bottom is simply just all of those outcomes, A plus B, choose n of them. So if that's the case, and that gives us our probability of NA over NS, this seems pretty complicated, but it really isn't. Let's take a look at example number 1. So here it says, determine the distribution for the number of women on a civil court jury of 6 selected from a pool of 8 men and 10 women. If we're finding the distribution for the number of women, that automatically becomes our x. We're looking for women on this jury of 6. And we have 10 women to pick from and 8 men. So let's start by defining what our successful and unsuccessful groups are. A is the group of successful things. Well, if we're looking for women, then that would be 10 women in that group. B, unsuccessful, that's the 8 men. If a man ends up on the jury, we're counting that as a failure or unsuccessful event. N here, what's the N? Trials? Well, we have to make a jury of 6, so that's 6. We are selecting 6 people, so N is 6 trials. And we don't have an X because it asks for the distribution. Distribution is all X. Let's start with our chart, X and PX. We won't have room for all of these, but we'll do some. Let's think about this. How many ways could this happen? If X represents the number of women on this jury, we could have 0 women on this jury, or 1 woman, or 2 women, ... or all the way down to 6 women total on the jury. And if we have 0 women on the jury, what's the probability of that happening? Let's think about it. So out of 10 women we could have picked from, we chose none of them. That's the same thing as up here, A, choose X. Out of the 8 men, we must have chosen all 6 to be men of these jurors. That's B, choose n minus x, or 6 minus 0. Divided by, on the bottom here it says A plus B divided by n, because unrestricted we had 18 people technically to pick from, and we had to choose 6 of them. That's our NS. Okay. So 8, choose 6, divided by 18, choose 6, is equal to 0.0015, or 0.15%. I'm going to skip 1 because I'm going to run out of room, but I am going to go to 2 next. So I've done 0, let's try 2. Let's set up 2. Thinking about that same formula. If 2 women ended up on this jury of 6, that means out of the successful group of women, 10, we chose 2 of them. order doesn't matter. We chose to, not permuted to. That's important. And out of the unsuccessful group of men, we chose, well, if there's 2 women on the jury, there must be 4 men on the jury, because 2 plus 4 adds up to 6, right? Divided by 18, choose 6. Gives us our answer. We'll do that last one now. 10, choose 2, times 8, choose 4, divided by 18, choose 6, gives me a 16.97% chance, or 0.1697. And you could do that for all of these all the way down. I did not do one. I skipped one. I skipped 3, 4, 5, 6. But really, for a distribution, you would need to do all of those, all 7 of those probabilities calculated out. Okay? I've given you an example, at least, of how to do it. Part B, what is the probability that there are at least 2 women in the jury? At least 2 women in the jury means 2 or more. So we're talking about this group here, 2, 3, 4, 5, and 6. I don't want to have to add up all of those outcomes when I know that the sum of all these probabilities would add up to 1. So we're going to say that the probability of our random variable x being greater than or equal to 2, that's what at least 2 women means, is equal to 1, that's 100%, or the total, minus the probability that x equals, what don't we want here then? We don't want 0 women on the jury. That's not at least 2. And we don't want 1 woman on the jury. That's not at least 2 either. So we have 2 cases we have to subtract here away from our total of 1. I'll let you figure out how to do that. I've already calculated 0 for you. So that's done. I'll let you set up this probability of x equal to 1. If you want to pause the video here and try it yourself, it's a good chance, and then unpause it to get your answer. Okay, here is the answer to this one. So to set this up for x equals 1, we have 10 women. We need to choose one of them. We have 8 men. We have to choose how many? 5, that's right, because there's a jury of 6 still. Divided by 18, choose 6. And when you calculate all of that, you should get your final answer here.